Hi, so I was recently watching a really interesting teardown by YouTube user Treagle124, looking at very expensive Sun SPARC server systems which had some amazing build quality. I'd highly recommend you watch that video. And I was sort of quite interested to get a closer up view of some of this stuff, so I had a quick hunt on eBay and found this. This is just one of the CPU modules out of the server. List price 2013, list price $20,000, £26 on eBay. I've already taken a lot of the screws out of this, but I just really wanted to take a closer look at some of the sort of the finer details of it. On top there's this plastic cover, and the main purpose of this is for ducting the airflow. This thing's got colossal fans in it, so there's just sort of plastic covers everywhere just to direct the airflow to the right place. And this is basically a dual CPU unit, so I've already taken the screws out. So the actual heat sinks, massive chunky heat sinks, which are held down by these really nice sort of spring screws. So this sort of screws down, and then the spring actually maintains a constant spring pressure on the heatsink down onto the processor. And this is all mounted in a metal tray, so it sits in there. These are the plates that go on the back of the CPU, and it's got this really nice release lever, so we've got like a lock there. You sort of unlock that and then pull that out, and that then obviously pushes against the rail and releases the whole module out of the system. But this is a really nice sort of solid, I don't know if it's cast or machined or a bit of both, but it's a really super nice feeling handle. And this is a stainless steel plate with all sort of various cutouts and angle folds for rigidity. And here's the board with these very nice, very shiny gold surface CPU packages. It's got this thermal interface material, this sort of hexagonal pattern. I'm not quite sure what's, probably just about getting the right amount of compression and heat transfer. And the other thing on the all of these DC-DC converters, the whole system runs on 48 volts. So each CPU has two of these power converter modules. So these are clearly designed to sort of go from the 48 volts input down to a very low voltage for the CPU. This looks like a sort of probably a four-phase converter. You've got the drive MOSFETs here, and then output MOSFETs for output rectification, and these are in sets of three, all in parallel. On so I think these are on the four phases with three MOSFETs each, with this planar transformer, which is basically a ferrite core around PCB tracks, and this is probably multi-layer with winding layers on windings on each layer of the PCB. I have tried powering this up, but it just sits there, draws about 200 milliamps, because there's all sorts of enable stuff to actually turn everything on, get everything happening. So didn't really expect it to do much. There's not much capacitance on here. All the capacitors are on board. All these big chunky ceramics, these are all 100 microfarad ceramics, and then there's loads of these polymer capacitors, 2700 microfarad, 2.5 volt polymer caps. That's seven on each section, and these big 330 microfarad input caps. And so there's some unpopulated areas. Obviously, maybe for the higher power ones they need more modules, so they actually fit some extra. One thing was a little bit surprising, there isn't actually anything actively holding these things in, and if you look at the other video you see that the mechanical construction is pretty robust, but actually when I received these, one of these had actually popped out. There isn't even any not even any ridges or anything in here to actually push these down, which I thought was rather surprising. I don't know if there's maybe an extra piece that's perhaps missing, and there are a few holes in there that there could be some sort of screw down thing on there to hold, but that's a little bit surprising. This thing is sort of built for super high reliability, but you'd expect there'd be something to actually hold these things down. Modules here. Now the one sort of striking thing about this PCB is the thickness. This is about 3.8mm thick PCB with no doubt a huge number of layers and a lot of power planes and sort of power layers in there. I have tried x-raying this, but it's just far too opaque for my x-ray to see anything except the vias, so unfortunately it would be nice to actually see a nice sort of high power x-ray of this, but that's unfortunately not going to happen. Now the only through-hole parts are these connectors here, and these are actually press fit, they're not soldered in, because obviously trying to solder to a PCB like that with all these ground planes would be pretty difficult, so these are actually press fit with a specially shaped pin that goes into a hole in the PCB. See if we can actually unpress fit these. Yeah, these do actually come off. And if you take a close look at these, you see the actual pins have a little gap in the middle, so that they actively, there's some active spring pressure pressing against the side, the through-plated sides of the holes to make contact. These appear to be in section. I doubt they press this whole thing down in one go. I don't know whether, I sort of just forced it off, this did split into separate sections, but they also appear to be in blocks. I'm not quite sure how big a chunk gets fitted at a time, but I doubt it fits this whole one purely because of the sheer amount of force that would be needed to do that. And if you take a look at these are alternately, every other set of pins is basically a ground. So this is for, obviously these are sending lots of high-speed signals, so you've got grounds between each row of pins, and this is just like a stamped section of just diagonal, just sort of stamped sections for each pin going down to the PCB. And these two grey ones are for the power, so these are just big chunky connections, so there's one each of these for the ground and 48 volt supply. I just looked these connectors up on DigiKey. Each of these sections is £27 in 100 off quantities, so there's well over 100 quid's worth of just edge connector before you start looking at the rest of it. Now, apart from the CPUs and the power module, there's not really a great deal else. All this circuitry here, there's some D to A converters, some I2C to digital output I/O expanders, and some analog switches. So this is, I'm sure this is all going to be about voltage, controlling the supply to the voltage supply to these CPUs. There doesn't really seem to be anything at all in the way of actual signal processing. So these CPUs are just basically going straight to these connectors and being provided power from these converters. The memories are on separate boards. What I think it's a little bit surprising is I'd be surprised there's no E2 prom just to have some board ID and serial number information in machine readable form, but doesn't seem to be anything like that as far as I can tell. And on the bottom side there's actually a cutout underneath the CPU. You can see a few components mounted on the underside. Not quite sure what those are. Now, these ones at the bottom look like they're probably capacitor arrays. Not really sure, these may be inductors or something. Little BGA packages, and I'm not quite sure what that blue component is, but I think we'll attempt to blast this with some hot air and see if we can pull these CPUs off. If we can replicate the method I used for that first one. Yep, that works. One interesting feature I noticed on the original video is that there's almost no track routing on the top layer. Almost all the components just go straight into vias to inner layers. Now obviously that's presumably just to make the whole routing process easier and make it easier to make changes. Because obviously once everything's onto inner layers, then it can just be routed almost like sort of the old through-hole type boards without having to worry about where the components are. Quite possibly with some very expensive auto routing software. But say there's apart from these little fan outs, where is it? Yeah, apart from just areas like here where they go straight to these resistors, pretty much everything just goes straight into vias and then disappears into the inner layers. And obviously where the high current stuff, you've got multiple ones here, and also on, I noticed in some of the capacitors you've got two vias. Now I'm not sure whether that's just duplication or whether you actually got signals that go in, across and then down to reduce the series inductance with the capacitor there. But it's not something I've actually seen before, but then again I haven't really seen that many very high layer count PCBs close up. This seems to be just a solid metal slug of copper. You can just about see the copper colour through the gold. Not really quite sure why they gold plated this, other than bling factor. So all this is doing is providing a sort of thermal contact to the heatsink. So I'm not really sure, other than sort of preventing oxidization. I'm surprised that there isn't a cheaper option than gold from that, but it looks pretty anyway. So let's see if we can unsolder this somehow. You can see one massive lump of silicon in there. So it's about 21 millimeters across, so don't get too many of those to a wafer. It looks like the back is sort of soldered on to the top plate. So I think the top of that, yeah, so this is the back of the die, so I think the top is sort of, there'll be bumps on the front of that go onto this ceramic carrier, so I'm not sure if we're going to be able to separate that without catastrophic damage, but we'll give it a go. Now, I couldn't immediately see any interesting features on the piece of silicon I did manage to get off in one piece. There did seem to be quite a lot of copper on the surface, so I've chucked it into some ferric chloride for a while just to see if we can etch down to anything interesting, but I think any features are going to be too dense to see anything. This is the ceramic piece, so this links the BGA pads here onto the actual silicon, and so you can see some very high density array of solder pads that goes onto the face of the silicon die. There's a huge number of these, looks like there's a lot more than there are balls here, but obviously a lot of those are going to be power and ground connections just in parallel to minimise the resistance. I've tried X-raying this, but the ceramic is fairly opaque, but also the copper is going to be extremely thin, so I don't really get anything. I can just about make out these surface tracks, but I can't really see anything inside. So I'll just ground a little bit away with just a diamond wheel, just to sort of have a look. You can certainly see a few layers in there, but it's obviously difficult to see exactly how many, because they're quite close together. But you can see some fairly sort of solid, sort of plain layers, which would be power and ground. I've no idea how many layers are in this thing or how it's actually constructed, but because it's ceramic, it's a bit hard to do anything with. Now, I haven't really found a decent way of scraping the interconnect layer off the top of this chip. It's had 24 hours in ferric chloride, but although it looks like copper, it did take a few little bits of the copper off. But there's, you can see a bit of the underlying chip, sort of the colourful bits underneath. But I've not found a way of just peeling that layer off to see the chip. But so it's certainly a very impressive sized piece of silicon. If anyone's got any suggestions, let me know, because I still do have that other chip in one piece at the moment. Well, I do have some further plans for this PCB, but they will take a little bit of time. The reason I'm out here is it's a little bit noisy, but I'll give you a little sneak preview.